Before we go much deeper into processing user input and processing options from the command line, I want to revisit something from Chapter 12. I did not do video content on the case statement at the end of Chapter 12. That's on pages 327 to 328. I suggested that you take a look at that on your own, but thought I would go through it real quickly just to bring it back to your remembrance, or if you didn't get a chance to look at that before, to make sure that you have that, because we'll make use of it as we get a little more sophisticated about reading the command line parameters here in this section. So let me just bring up an example. This is related to the example that's on pages 327 and 328, but I kind of made it my own. So take a look at this. This is a kind of commonly done thing, logic-wise, that we need to do when we're processing user input. So we'll have something like this. We go ahead and grab whatever $1 is. Maybe we stuff that into a variable, or maybe we just use $1 below. But so num is now equal to $1. What is that? Well, that's the first parameter after the name of the thing, right? And so then, depending upon what that thing is that the user provided on the command line after they gave the name of the script, depending upon what the user has entered, we'll do different things. So for example, in this case, this is really simple, right? If it's the case that num is equal to 1, then we'll echo one message. Okay. Otherwise, if it's the case that num is equal to 2, then there's some other message. And otherwise, if it's equal to 3, then there's a different message. And if it's equal to 4, then there's a different message. And if it's equal to 5, then there's a different message. And in any other case, then we echo this final message. So you have if then, elif then, elif then, elif then, elif then, else, and then phi. So it's a little bit cumbersome to deal with, but certainly it will work. Let me demonstrate that for you. Let's execute that with the number 1, and you get that. And if I execute it with 4, I get that. And if I execute it with 5, there we go. And if I execute it with 77, then I get that. Okay, so fine. It works. It's a little bit cumbersome. The case statement can make it a little less cumbersome. And let me show you what that looks like. Here's another version that does exactly the same thing. Now you'll notice immediately it's much shorter. Okay, so this line is the same in both cases. But now instead of if, elif, 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 else, and then phi, okay, instead of all of that, we have just it's much shorter vertically, right? There's just not as much here, but it's going to do exactly the same thing. So let's interpret this. The way the statement works is we have the word case, as you see right there, and then the variable, and then the special word in, and then we have some various conditions, and then to the bottom here is case spelled backwards. Looks like ESAC, right? But it's just case spelled backwards. So there's the case, and there's the end of the case statement. Okay, so case, variable, in, all the various conditions, and then the bottom one. So what are these? How do these work? Well, you've got a particular condition like this. So if num is, the way we read this is, if num is equal to 1, and the closed paren there is just part of the syntax of the case statement, okay? So if num is equal to 1, then we do this command, and any number of commands. You could put in 20 commands there, but the main thing is that when we're done with all the commands, it could be 20 lines or whatever, but when we're done with that case, we have 2 semicolons right in a row. That's just hit semicolon, semicolon. There's not a space in between those. It just kind of looks like it because of the way that the font is spaced, okay? But there's no space there. It's just semicolon, semicolon. And that means when you're done processing this, then go ahead and exit the case statement. So once it finds one that matches, it exits the case statement, okay? So if number is 1, do this. If number is 2, do this. If number is 3, you do this. If number is 4, you do this. If number is 5, you do this. And then finally, asterisk is a special character. That means in any other case. So that corresponds to our else in the earlier version that we looked at. Okay, so this does exactly the same thing. And let's just execute that with some of the same kinds of inputs. And 3 and 4. Okay, so it works exactly the same way. So again, what's the advantage here? Well, the advantage here is that's how long that one is, and that's how long that one is. Which one do you like better? Well, you know, the case statement is very handy, right? So this is a good one to know and to use to make your code a little bit more concise when you have a situation like that would have all of these if such and such, then, and then elif such and such, then, elif such and such. You see, you start building this kind of chain of if, elif, 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 elif. Then you should start thinking, I wonder if I could use a case statement there. Now, one thing about it is that the case statement only checks equality. So num is equal to 1 or equal to 2, equal to 3. If you needed to say, hey, if number is less than this and greater than this, or if it's greater than this and less than or equal to this, or something like that, then you wouldn't be able to use the case statement for that. It's only in cases where we have equality. Okay, so good tool to know. And with that, then let's move on to the getops command. Okay, so let's take a look at this is chapter 14, test 19. At least it's very close to the one that's in the text. I shortened it a little bit, and I'm going to show you how to use the getops command. Getops is a tool that allows us to grab options from commands that are using kind of the standard bash format, which has the dash symbol, otherwise known as the minus sign, right, and then a letter. So you've seen this in various commands, like ls-l, for instance. The -l is an option for a command. So you're used to seeing that. Well, you can make your own bash scripts kind of behave the same way. And this is very, very handy to whoever else might be using your script, or indeed to you, when your scripts behave just like little extensions of bash. I mean, that's kind of awesome, right? You can basically make your own commands to do whatever you want to. So this is a very flexible way of working. But you want to be able to get the options from the command line. So how do you do it? The book goes through different ways of doing this, including a less sophisticated command called getopt, that is without the s at the end. Notice this is the getOpts command with the s at the end. So I'm skipping over and going right to kind of the one that's a little more sophisticated and does a little bit better job. I don't know why you'd necessarily, I mean, certainly for reading someone else's scripts, it might be handy to know the other one is there. So I mention it, and it's good to know that it's there in the text. You should have a look at it. But you know, I don't think it's strictly necessary that we go through all that just to say, okay, there's a better way to do it. So here's the better way to do it. We use getops. So getops takes two parameters. The first parameter is a list of the options that can be received. It's like an option kind of format string thing. So I will show you other things that we can do, that we can add to this to do different kinds of things. But right now we'll start with the simplest case. What options are available here? Well, there's A, there's B, and there's C. So that's basically what that means, that I have the ability to read those options. Those are the ones that are valid for this particular script. Okay. Now then, the next parameter here, OPT in my case, just kind of a common name. It means the option. Okay. That is just a variable name, so I could call that Mickey Mouse if I wanted to, but I called it OPT for option. So we'll use getops in a while loop, and the purpose here is to go ahead and capture or deal with all of the options that are in that command string. We'll look at different ways that we can deal with those, but right now I just want to keep it really simple. We'll say while it is the case that getops A, B, C into opt. Okay, so opt is the variable that's going to be used. Then do the following. So what's this going to do? This is a loop, right? And so every time through the loop, OPT is going to contain a new option. It's going to read them from left to right, and it's looking for the options A, B, and C. Okay, those are the ones that are acceptable here for getops. Okay, so now then, what's it going to do? OPT then is equal to whatever the first option is the first time through, and the second time through it's equal to whatever the second option is, etc., till I run out of options. Okay. So if it is the case that OPT happens to have the value A, then in this case we'll just echo, hey, I got the A option. So now I could do something else there. Obviously this isn't very helpful just saying, hey, here's what you gave me. But before very long at all, just in a few minutes, we'll see what else we might be able to do with that information. B, echo, hey, I got the B option. C, echo, I got the C option. And asterisk, unknown option, whatever it is. Okay, so let's just exit there. And let's go ahead and run this thing. So we'll say chapter 14, test 19, and obviously if I have no options, then there's nothing interesting there. If I say dash A, guess what? It got the A option. What about dash A B? Hey, it got the A option and the B option. What about dash AC and then dash B? Hey, it got all of them. Notice it's in the order that they were given. So remember how you can combine those things. The order shouldn't necessarily matter, although there are a few commands. I think, as I recall, when we went through the tar command, we realized that the order of those things actually matters. Guess what? They're not using getops, are they? They're using some other way of parsing this. So if you use a more sophisticated tool like this, it just kind of handles it for you. So, hey, it got the A option, the C option, and the B option. Let's add one more option, the dash X option, and it says, first of all, I get a report from bash. It was an illegal option. Remember how we supplied to getops the string of legal options? So it actually does generate an error, but it goes ahead and continues running anyway. So the asterisk then allows us to add kind of a custom message to that. But in this case, we've got two possible ways of handling that error. So anyway, let's go back into it and let's see what else we can do. Sometimes when we have options, we might want to ensure that certain options always take a parameter. Okay, so for example, maybe I want to, instead of B, let's change it to F. Okay, so we'll say getops A, F, and C, and so this is going to be the dash F option, but what we're going to say is that the dash F option specifies a file, we'll say, okay, for our particular script. So if you have the F option, it requires that there be a parameter following it. The way we indicate that is we just put a colon after the F, okay? So this has options A, F, and C, and F requires that there be a parameter following it. If you have an F option, but then you don't specify a parameter following it, then that's going to be an error. So in this case, let's indicate what the parameter was that was following it. And here's how you do it. You can say, hey, I got the F option, and the parameter is, and the way that you use this is optarg. That variable that is set is the argument that belongs to that particular option. Now again, we can do something else with that. Right now we're just going to print them out just so that we see. Okay, and then let's go ahead and write that out and exit. And so now we want a dash F option, and it says, oh, you know, there's a problem here because this option requires an argument. Okay, so what argument does it require? It's a file name, right? So I'll just say some file, okay? And so now I got the A option, the C option, I got the F option this time with the parameter some file. And of course, you know, once again, order doesn't necessarily matter, but of course the parameter for the dash F has to immediately follow the dash F, but I could say dash F, some file, and dash A if I like. So I got the dash A option and the dash F option with a parameter some file. So that's how we would have options that require parameters, and we'd be able to work those into our script. So now then, what do we want to do with this information? Well, one thing that we could do is we can have this at the top of our script, and we can save this stuff off as variables. So what I could do is say something like opt A equals 0, and opt, what do we have, C equals 0, and opt file equals, and I'll just indicate something like this. So those are kind of our defaults. And so what I could do here is change this. I'll say if we get the A option, then we'll say opt A equals 1. How's that? If we get the F option, then let's do this. We'll say that opt file equals, and it's whatever is in opt_arg. And if we get the C option, let's do the same thing. That is to say, we'll say that opt C equals 1. Okay. So what does that do for us? Well, now when I go down here, I can make use of those variables in some way. I will say options supplied, and we'll just do it this way. We'll say -n, and then we'll say if it is the case that opt A equals 1, then we can echo what? We'll say A and then a space, or maybe -A. Okay. Okay. Here, let me break these up a little bit. I'll just do it this way. We'll then echo and phi, and we'll say if it is the case that opt C dash equals 1, then echo -C with a space. Oh, I want those to be no new line character. I want to be on the same line, so let me fix that real quick. So -n, okay, and phi, and then we can say finally that if it is the case that what do we want to compare? We want to see if OPT file. What do we want to know? We just really want to know if it's got a length greater than 0, right? So how do we do that? Pretty sure that's the -n, isn't it? It's -z for length 0 and -n for not 0, right? So if that has a non-zero length, remember the default was it has a 0 length. There's nothing in there, right? So if that's the case, then we will echo, how about -f, and then we want to know the file name, right? So how about we'll just use that. What do we call it up there? I have to look. It's OPT file, right? Okay, so I sent OPT file like so, and then we'll just echo to terminate the line. So let's write that and see what we can do. And we'll say -A, -C, and -f with some file. So that'll capture everything. Oops, I have a problem there. Let's see. Integer expression expected on line 17. So let's look at it real quick. Oh, let's see which one. Integer expression expected. That's right here. If OPTA dash equals 1. Oh, you see what my problem is, right? It's so easy to do this. $sign right there. Get rid of that extra space. $sign right there. So easy to forget that stuff, isn't it? $sign, whoops. And here I got a %sign in there. I just noticed that. That's a $sign. Okay. So you're not the only one who does that stuff, right? Okay. Let's see if that gets it. There it is. And so there are your options that are supplied, A, C, and some file. And of course, if I eliminate some of them, change the order, there we go. I still get the same options. Okay, so what have we accomplished here by sticking them into variables? Well, what we've accomplished is I've got a section up at the top that basically parses all the options and sets some variables for me that I can use later in my script. I could do anything with those variables, right? If it is the case that OPT file has non-zero length, then maybe I want to redirect output to a file. Otherwise, I just go ahead and send it to the standard output, that kind of thing. Okay, so we can make choices then as we go. So that takes us essentially to the end of what I wanted to cover with you for this week. That is to say that we've been able to receive user input from the command line. We've been able to parse all of the parameters there. We found different ways of using the positional variables to get at those. Also shift in order to make one fall off the left side and shift everything to the left one so that we could parse them that way in a loop if we wanted to. We found a way to gather them all together and use a for each loop to go through them. And then we've also figured out this this new thing, obviously using the I can't think, getops command, right, with its string in order to parse things. How we could have options using the standard bash syntax of dash and then a character, or also use those where a parameter has to follow. And I guess the only other thing to consider is what happens if after all these options, if we have some other parameters that follow them. I think I should probably show you that real quick. Remember, our shift command allows us to shift the all of the inputs to the left, and if we just say shift and leave it alone there, it's going to move it by 1. However, after we've processed certain things using getops, there's another variable that will have been set, which is optind, or opt-ind for opt-index. That basically tells us how many options we have processed. So if we will shift to the left, that quantity minus 1, it actually tells us the index of the next option. But if we'll shift that many to the left minus 1, so we'll do something like this. This just makes an expression, of course. Remember, that's the alternative syntax for eval. And we'll use optind minus 1 right there. So what does that do? That's going to shift all the options we just read off. And so now then, the next thing that's at $1 is whatever came after all the options. Because remember, we can have other things besides options. We might have other parameters as well. So for example, you could have a command that says, delete, all of these files if they're smaller than a certain size. You could make a script that would do that. And then you would provide a list of file names after any options, and so that it could be more than one file at a time. It could be many files at a time. Okay, so something like that. So let's shift those, and now let's see if we can process the parameters. And the easiest way to do that is probably using a for each loop. So we'll just say I'll use parm for parameter. So for parm in, remember, we can use that to indicate all of the things that are left. We've just shifted a bunch of stuff off, right? So this should be all the parameters that are remaining. And we'll just do and done. And what do we want to do in between there? We can say, how about echo parameters? I don't really want to do that. Hold on. Let's just say this. We'll do that. We'll do that up here. Echo parameters, and why don't we not put a new line character there? And so what can we do here? We can just go ahead and echo parm. How about that? And why don't we put a space after it so that we can separate those. Okay, so that'll work. So now we're going to have a list of parameters, and let's see, when that's done, we'll go ahead and echo so that we end the line, and then we get options supplied on the next line. Okay, so let me write that, and let's try one more example, and we'll say, you know, param1 and param2 and hello and there. Okay, so now if I do this, notice that I have a list of parameters that come out, and then the options that are supplied. Let me go back in there because it didn't quite, it stuck some line numbers in there that I didn't want. So it's right there. Turn that off. I'm a little OCD about stuff like that. So that's better. So now I have my list of parameters, and then I have my list of options that are supplied. So now with that then, we have certainly gotten to the end of the content. So that's all for this. That should give you all of the tools that you need to be able to carry out both of the homework assignments, assignment 1 and assignment 2. I will tell you, they tend to be kind of like this script that we've just kind of grown right here. That is to say that they tend to be a little on the longer side. Some of the conditions and things you know, that you have to satisfy require a little bit of logic. You're going to use some loops. You're going to use some if-then statements, and you'll be using get-ops in order to complete those 2 assignments. So they tend to be a little longer, 30, 40, you know, up to as many as about 50 lines. This particular script right here that I've shown you here is 39 lines, but it doesn't get more complex than this. So those are the tools that you'll need for those assignments, but I'd urge you, don't start those like, you know, the evening of or something, because they might take a little bit longer to get done. So good luck with that. Let me know if you have any issues with it, and we'll wrap up this bash scripting stuff probably just about the time we get back from spring break. We'll be about done with that, and we will then shift gears a little bit and move over to the Windows side and see what we can learn about some of the shell commands and such on Windows. Something new there called PowerShell, and also just a little bit of light scripting, enough that you could certainly proceed on your own and continue to grow in your knowledge of those things. And that'll make the course. So until next time, bye.